All right, welcome back for part 2 of 1.6 to 1.8. We're going to finish up to 1.7 and then move on to 1.8. We're still talking about domains. We're just going to go through each one of these, kind of talk about what's going to happen in each one, and then move forward from there. So, first one says f of x is equal to the square root of x plus 1. Above it said that if you want to find what it is that you're allowed to do here, all you had to do was take whatever's inside the radical, set it equal to 0, and solve. So, x is equal to negative 1. Well, that tells me then that my domain is going to be that, in this case, if I put in negative 1, I get 0. Square root of 0 still works. So, that tells me that I can start with negative 1. And in terms of interval notation, I'm going to include negative 1. So, negative 1, and it can go as high as infinity. The other way we would write this, but keep in mind we do use interval notation for the most part. This would also be saying x can be greater than or equal to negative 1. So either of those answers would work right now. The next one says f of x is equal to 2 over the sum of x squared minus 6x plus 5, or the quantity of. So, in one like this, what we're going to need to do first is we're going to set the denominator equal to 0, just like they said before. X squared minus 6x plus 5 is equal to 0. Well, that tells me then that I've got a quadratic here that I need to factor. I'm going to use the x. This is factors of 5 that are going to add up to negative 6. Well, that would be negative 5 and negative 1. That tells me this is x minus 5 and x minus 1. Those are both going to equal 0, which means x is going to equal 5 and 1. Now, those two values would be what makes the bottom 0. And since we can't have the bottom equaling 0, we know then that there are two ways we're going to write this. Either for our domain, x cannot equal 1 and 5, or if we're going to say this in interval notation, it's going to say everything from negative infinity up to 1. We don't include 1 because it would make a 0, in union with everything from 1 up to 5. We don't include either of those, in union with everything from 5 to infinity. So, two different ways of writing this one, which creates our answer. The next one, this is g of x is equal to log of x minus 9. So, same idea, start by saying x minus 9 equals 0 and x is equal to 9. But when you put 9 in right here, you're going to get log 0. And as we talked about in the last video, the log base 10 of 0 does not exist. So, since this does not exist, we can't actually use 9. But could we use something slightly bigger than 9? Well, as long as it comes out to be a positive value, the answer to that is yes. So it tells me that for this one, either x has to be greater than 9, or we can say it in interval notation that it's going to be 9 to infinity, and we are not including the 9. Domains. Those are our domains. Hopefully everybody sees how that works. Let's move on to this next part. For each of the following in 6 through 8, we're going to write the given function r of x as a composition of the following functions. So they're giving us 4 functions, just like they did earlier. But the difference to this is now I want to actually write the 2 functions that if I put them together, it would give me r of x. So, looking at the first one, it says r of x. I'm going to just stick with, well, we'll see here. This first one here, I see they have a log, so I know it has to include f of x. And it's got a 5x minus 9. Well, it's got a g of x here. So, for this one, we would say the following. We would say then that f of x is going to equal the log of x, and g of x would equal, 5 of x, that would be 5x minus 9. So this one would be an f of g of x. So we would say f of g of x. This is how we would write this in terms of basically a composition of the two functions. Hopefully we see that. The next one is saying r of x is equal to the square root of x of 10x minus 18. Well, I'm looking up here and I see here's a square root function. Then I need to figure out how I'm going to get to 10x minus 18. I don't see anything, but I do see the g of x right here. And if I were to multiply that by 2, that would give me 10x minus 18. So the way we would write this one, I have h of x, which has to be on the outside here. So h of g of x, so g, but remember, before I write g of x, we have to multiply g of x by 2. So 2 times g of x. Everybody see that? I hope that's clear in terms of how we want to get to an answer. Let's look at this number 8. In this one, it's saying 4 over the natural log of 5x minus 9. So I'm looking up here at the top. I'm not exactly seeing everything here, so I've got to figure out what I'm going to do for this one. We have to kind of parse this out. Keeping in mind there's a fractional one, so it's saying I got to use j of x. I see a natural log, so that means k of x, and I see a 5x, so I need g of x. And now I just need to figure out how I'm going to put those all together. Keeping in mind that j of x is the fraction, so I probably have to start with j of x. And then, once I have the fraction, I'm probably going to have to use this next one, which would be k, because that would be the ln of x part. And then I would need to use g. And now I'm just missing one other piece, which this was a 4 right here instead of a 2. So if I just multiply the front of this by 2, I should get the composition that I would need if I were to put all of those together. Remember, what this is saying is you take whatever g of x is, which is 5x minus 9, you plug it into k of x. So that would mean the natural log of 5x minus 9. And then whatever that answer is, you're going to plug it into j. Well, j has an x at the bottom, so you're saying it's going to be natural log of 5x minus 9. And then since I need that extra 2 at the top to make this 4, I'm going to multiply the whole thing by 2. Composites of functions. Now, this next part is really the same idea. The only difference in this next part is that for each of the Rx's, they want us to write them as a composition of functions. So I'm just going to pick this right now. You don't have to do it like this, but this is how I'm going to pick it. I'm going to say f of g of x. I'm going to write all of my answers in that form. That just makes it easy for me to plug things in. And when I go to do this, I don't necessarily have to do that. I may change it at the very end and do something different, but that's really all I need to do here. Don't get too crazy with these, and believe me when I say there are a lot of different answers, so don't freak out, okay? First one, I know that f has to be on the outside. I know that g has to be on the inside. So I'm going to say the following, g of x. Well, I'm looking at this piece right here. If I say g of x is 2x plus 4, then what could f of x be? Well, it could end up being x cubed plus 7. That would give us, when I compose those as f of g of x, the answer that they're looking for, r of x. How about this next one? We have a cube root of x minus 4 plus 1. So once again, f has to be on the outside, g has to be on the inside. So if I just look at the inside, I could say g of x is equal to x minus 4. And so the upper part of this would then be the cube root of x plus 1. Remember, the idea is to be simple here, to make this a simple answer. And also keep in mind, you have to state this. Otherwise, you're kind of leaving it up to somebody to guess what you're going to do. So either state it there or state it at the bottom of each of the problems that you work out. This last one, r of x, and it's saying 4 over ln of x plus 5. Well, here's the outside function. Here would be the inside function. And in this case, the inside, I could just do it like that last problem and say this is ln of x plus 5. And then I could say for the top, this is 4 over x. And that would give me what I'm looking for. So make it simple. We could have done this in 3 parts. We could have said f of x is 4 over x. We could have said g of x was ln of just x. And then we could have said h of x was x plus 5 if you wanted to get that involved. But don't take it all the way to there. It's not necessary that you do that. The last part of this is talking about inverses. So in order to find an inverse, you are going to switch x and y and solve for y. Inverses are always symmetric with respect to the line y equals x. If f of x and g of x are inverses, then taking the f of g of x function and the g of f of x function, you will find your answer ends up being x. And it has to work in both instances. So let's take a look at this first one. Find the inverse of each and state whether the inverse is a function, right? Yes or no. So that's the first part. And then show that they are inverses by composing the functions. Do this check on number 13 only. So show that they are inverses by composing. So this is the only one that we're going to compose, meaning this last part right here that we talked about up here at the top. So find the inverse and state if it's an inverse. Inverse of a linear function is still a linear function. So we will see that in just a moment. Switch our x and y. Remember, this is another name for y. So we switch our x and y. That says x is equal to 3y minus 2. Then we're going to solve. X plus 2 is equal to 3y. And now, y, sorry, I want to do this just to make sure we understand it. When I divide by 3, I'm going to get x plus 2 over 3. We could leave it like that, or we could say it is 1/3 of x plus 2. Or we could say this is x over 3 plus 2 over 3. They're all the same answers, they're just a different way of writing all of them. What they want to know here is their inverse. So when you say inverse, you need to say the following. The inverse of f of x, this little symbol up here, this little dash, apostrophe, whatever you want to call it, it is telling you that it is the inverse of this thing. And the inverse of this, I'll just put it in that form. I'll say it's 1/3 x plus 2. That is the inverse. Now, is this a function? Well, for this particular one, it's still a line. X still has a power of 1, so this is still a function. This would be a yes. For this next one, h of x is equal to this. So this is a quadratic. So now, we'll do this one. It says to show that they are inverses by composing the functions. And we're only doing this for number 13. So if we take that same concept into play here, we are going to say the following. We're going to switch our x and y, so we have x is equal to, this is y minus 1 squared minus 4. We're going to take we're going to subtract or add the 4 to both sides. Remember here, we don't want to square y minus 1. We just want to do what's opposite, take the square root. So we're going to have something that says y minus 1 is equal to, this is going to be the square root of x plus 4. Now we have to remember here that when we do something like this, we have to consider the fact that we are taking the square root of something. And when you take the square root of something and you are solving an equation, you have to have a plus or a minus. Now, once you have that, you're going to move the 1 to the other side. So we're going to have an h prime of x is equal to, this is going to say plus or minus square root of x plus 4 and then plus 1 on the outside. Here is the inverse function. This was all of this answer. Now the question is this an inverse? And they're saying we should do this by checking to see if this is going to work out. When you go to do this, they want us to take the original function, so here's our y, here's our x, and plug it in to the other function. In this case, let's take a look at it. We'll go through it. We're not really excited about this method, but it is one way to do this. The plus minus might cause you a problem at the beginning, but you'll understand once you do it. So we're replacing x with all of this. We're going to say h prime of x. That's the first one we're going to do. So h prime of x. That means we're going to do the following. We're going to take whatever h prime is and plug it into the first equation where we see an x. So h of x is going to equal, I don't want to write all of that inside there, so I'm just going to say h of x is going to equal the following. It's going to be replacing, so plus or minus the square root of, this is x plus 4 plus 1, all of that, minus 1, all of that is being squared, minus 4. So when you do the math here, you're going to say the following. This is going to say, let's clean it up a little bit. It says plus or minus. This is going to say the square root of x plus 4, all of that being squared, minus 4. We square what's inside here. When you square pluses and minuses, you're still always going to be positive. So this is just going to say x plus 4 minus 4. That would be the answer of x. So there's the first answer, showing you that these would be inverses. I will do the second one over here on the side, but I don't know that it's necessary for you to actually write it down because A, we don't have a lot of room, but I'll write this one. This one's going to say h prime of h of x. It means whatever h of x is, I'm going to plug it into h prime of that. So h of x is going to be all of this stuff, and I got to plug it inside this thing and do all this math. So we're going to have h prime, it's going to equal the following. It is going to be plus or minus the square root of, this is going to be substituting x for what h of x is. This is what h of x is. So we are taking all of that, substituting it for the x inside there, plus 1. That means we're going to have plus or minus. This is going to be the square root of, this is x minus 1, these are going to cancel, and you're going to get plus 1. This is squared. When you take the square root of this particular thing, you're going to get plus or minus, and this is the part that's kind of tricky in terms of this. When you go to do this, it's going to say x minus 1 plus 1. Well, you're going to end up canceling out your 1's, but now it's saying that x could be positive or x could be negative in this particular problem. Remember, they are inverses here. This one is not exactly the same here, so this would have to be a no in this case, because we could find it the other way. We don't take the positive part of that plus minus square root thing. But this, because we had to solve it, these aren't really going to be exactly the same. Okay, they will be, but they're two functions, not one at this point. I hope that makes sense to you here. Is this the inverse? Yes, this is the inverse function, but There's something else going on here that would require us to have to think a little more about this one. And if we just take a quick look at it, the first one, if we said it was -4, so we're going to shift this left 4 and up 1. So it's going to look something like this. And when we go to do the other one, we're going to see it's going to do something like this. It's going to come over to this side. I think everything will be different. So it'll be down 1 and it'll be right 4. So down 1, right 4. So it's going to be something like this. And what we're going to see is that usually we only have half. So the half, the plus minus, is going to be the part that's a little bit different in this one. So we would have to make an adjustment there. For this next one, g of x is equal to 5 over x. So for this next one, when we try to find the inverse of this one, we're going to switch our x and y. So we have, this one's going to say x is equal to 5 over y. Going to multiply both sides by y. And then we're going to divide by x. And this would be a prime, so this is going to be 5 over x. And so our answer here, g prime is going to be, well, prime, but inverse of g is actually 5 over x. And it's the same exact answer. Sometimes that does happen. This is the inverse. And is the inverse going to be a function? This would be a yes. Back here, yep. So, in terms of this one, this next one, number 15, it's a natural log. This might be one of those problems that you're not going to be exactly familiar with because of the shortened year last year, so we'll kind of talk about this. Natural log just means log base e. So, first thing I'm going to do, I'm going to switch this around. I'm going to say natural log of, and I'm going to say this is y plus 8 is equal to x. So I switched my x and y, and I'm just moving the natural log to the left, because left to right equals the middle makes sense. This has an e as a base. So left to right, e to the x is equal to y plus 8. Subtract, we're going to get the inverse of y is equal to e to the x, and then all of that minus 8. This becomes our function. Sorry, this said yes. I didn't square that. Now, is this one a function? Well, yeah, this would be a function. There's really no other way. This is a yes here. This is a function. Because if we turn it the other way, it's still going to be, remember, it's going to, I'll do it down here in this, you don't have to do this, but it's going to look something like this, and it passes the vertical line test. Over here, graph both f of x equals x minus 2 cubed minus 1 and its inverse on the same axis. Use two colors and show the line of symmetry. So, remember the line of symmetry, I'm going to start there, because it's always y equals x. So it's always going to be a line that's basically coming through here. And it's saying y is equal to x. That's the line of symmetry. We stated that above. So the first one, it's saying f of x. This is a cube function. Cube function where we have an hk. H is equal to 2. K is equal to -1. And it normally would run right through the center, right through the axis here. But this one doesn't run that way. This one actually gets shifted to the right and one down. So it ends up right here. And it's a cube function, so it's going to start low, finish high, and it's going to get it's going to go over 1 and up 1, over to the left 1 and down 1, and then it's going to go 2 over and 8 up. 2, 3, 4, 5, 6, 7, 8. That goes up here, and 2 over from the center point, 2 over and 8 down. So 1, 2, 3, 4, 5, 6, 7, 8. Puts me just off here. This thing is going to be doing something like this. Whoops. Don't want to cross over that line, so I want to make sure I draw this correctly. It's going to just be skinny up through here and do this. Something like that. Now, the other one, the inverse of this function, we got to find the inverse first. So, to find the inverse, we got to switch our x and y. So we're going to have x is equal to, this is going to be y minus 2. We're going to cube that and say minus 1, so we're going to add 1 to both sides. We're going to take the cubed root of both sides, and we are going to add 2. So inverse of this function is going to be the cubed root of x plus 1 plus 2. So I have an h and k. Now this one's going to be opposite of what we just did. So this one, you're going to have an h is equal to negative 1. You're going to have a k value of 2. Just quickly pointing this out to you guys, what do you notice about your h and k in the second one versus the first one? Well, inverses mean opposites of each other. So things are opposite of what you had. Now it tells me I got to go left 1 and up 2. Here's my new center point. Now instead of this one going up and down, it's actually going left to right, and it's increasing from left to right. So I know this one's got to go 1 up here, this one's got to go 1 here. This one is going to go up 2 and over to the right. 1, 2, 3, 4, 5, 6, 7, 8. And if you notice, all of our points are across the y equals x line. All of them are going to be that way. This one's going to go down 2, and then 1, 2, 3, 4, 5, 6, 7, 8. So all of our points are mirrored through the y equals x line. It's going to come up through here. Oops, kind of went quick there. It's going to go through here. If you notice, they're both crossing right at that point, which they should. They should both be crossing each other at the y equals if they're going to touch. So in this case, that's our graph. Make sure we have arrows on both ends. I hope everyone sees this. I hope you see what we're talking about when we say that they are inverses on the same axis, so they are reflected through the y equals x line. This ends our lesson for 1.6 to 1.8, and we will see you in class on the next day, which will be whatever day you have, A or B. Have a good one. Bye.